Oh,
recently
yeah, I
started
know.
putting
And then the neighbors are all like, "Yeah, actually, you should park in our driveway. Working with
Oh,
her.
okay. All right. I have to figure out which is your
Yes,
driveway
yes.
and remember that.
Specific, my,
It's kind of this weird shared thing, which is so weird because there's so
like,
much
I know a
there.
lot
Like in
about
terms of
unit
the
coordination
curriculum,
and
right.
fractions and the
Thank
rest
you.
of it, like,
Yeah.
but
Um,
I'm
Yeah,
looking at
anyway.
it going,
Yeah,
wow,
yeah,
I
yeah.
know nothing
we're-
about
All right, I think we're ready to.
it. And so, we were practicing, I was having draw pictures and that kind of stuff, but like, wow, I need to.
Hello, everyone. I'm Jiqing Liu. I'm a son nurse now because you guys are the big people in this field, and I'm giving a talking here. I'm nervous, So because first I think, oh, just some graduate students talk with. So
I'm just a graduate student, you can look at me. I know nothing
I
about
have no
this.
status whatsoever, so.
okay, yeah. Anyway, I will try my best to give a conversation, and I wish to hear some feedbacks. So today the topic is finding the host on the umbrella, and we try to understand fifth graders fraction and decimal learning. So at the beginning,
Maybe just use the arrow button. Use the arrows.
this one?
Yeah.
Okay, thank you.
Let me just close this down here. There you go.
So first, I want you ask a question like, if we ask you to fix it's a broken umbrella without opening, how do you feel? So because when we have lots of tests from Teams, PISA, from their NAP, and from a big assessment, and we have a final assessment, seminar, tests. So we get a lot of it, and we get there something. We find there's some hole with students working. There's some mistakes, but finally, normally we give it a score. It's just impact or something, and then they give it to say and talk to teacher. Okay, please help to fix about this. So I think from teacher's perspective, okay, so we kind of, it's well known that that students, it's poor performance in fraction and decimal. It's because it's really challenging. We understand that. And we know that because they get no score on that test. And we compare to other countries, we have a higher expectation than that score. And however, that's because that's a huge assessment. We know neither about their specific how students' performance in fraction and decimal. And there's no specific instruction for teachers. And if I just got that information, say my English is poor, then I should try everywhere to improve my English. But if you tell me, okay, you pronounce the, it's not good, then I just go that one, right? So that's something we feel like, oh, it's so hard to change the situation so far. And I propose a more practical way. Is say, okay, we have test score, and let's just go back to each task to see how students perform on each task. And as teacher, if I can identify the challenge part of each task, then I can go back and I'm working with students, and I can also reflect, okay, what the problem with my instruction and what things surprised me from students' mistakes. Then I get some strategy to help them. Then I improve the students at least about this task. I cannot say I improve all the fraction, but if we saw one task, then they build the knowledge of students of fraction learning. So I think it's really important to see what is the real whole and umbrella. For example, we have a task here. You can also see from your handout. In order to solve this problem is asking students kind of easy model is you have 1/8 cup of flour, and then you use another 2/3 of the cup, and how much it's larger than 1 cup or it's smaller than 1 cup. So this has multiple ways to solve this problem, and students tend to use arithmetic way. It means they tend to get this number add together and get this number and then compare it. So we found normally they get arithmetic results and they then compare. They have two process. As a teacher, or if I want to look very generally, I have a question like students, it's able to compare well or it's able to find the result well. And if they have the similar, these kind of questions, that this kind of change was different tasks and what the potential instructional reason behind that. So that's we want to ask these three questions. First one is it challenge by comparison or calculation? The second one is to what extent it's a challenge for fifth graders for the same cross-related task. And the last one, we want to see if we can try to infer some reasons behind that. Okay, so we identify 4 tasks. You can see from the handout. Their similarities is they talking about fraction and decimal, and the last they need to compare the number with the whole number. That's the similarities, and this adding is from Ask project with PI. It's Eric Jepson. So, and I just identified that 4 tasks from their big assessment, and they include 203 students responding from 10 elementary classroom in this state. Yeah, and yes. So the process is first I just pay attention to 2 perspectives. One is the arithmetic operation results to see if it's right or wrong, or they did not do any work about that. They did not choose that strategy. The second one is the rational number comparison. Do they compare right? And then I kind of developed a cross table to see, to have 9 categories. So each student's work has a unique category code. And then, okay, here I show my process. If anybody wanted to go back the process, you can go. So it's really clear about what students' result and how make the decision. Normally because some students do not use the same strategy like arithmetic, we identify like there's no, that work show it. It doesn't mean they're wrong, but I mean they're not in this group. And the second, if the students, like, if even though they compare correct, maybe that doesn't mean they're all correct. Because like the students add these 2 numbers, get a 30, 11, but it's correct, right? No, this one is not correct, right? If this is smaller than 1, it's correct. It's compare correct. So that's the process. And let's see the finding. And if you cannot see clearly, you can see the handout. So first, we want to answer the questions of, is it comparer more challenge or the results more challenge? We found, like, you can see generally have a feeling it's students tend to compare correctly, but there's some reason behind that. Because like even the students get 1 ace and there's more than 1, we count it as compare correctly. So maybe sometimes they make a mistake about the result, but they compare correctly. And from this data, you can see this part. The second one is if you see incorrect comparison, you can see it varies a lot. And you can see kind of there's some problem of question 3 and question 4. And we will see why students really challenge in question 3 and question 4 in comparison. So because we think it's kind of like if that is a multiple choice questions, the last answer is ask then compare, right? And if we use a score, if they compare right, we kind of give them the whole credit, right? If they say, oh, it's larger than 1, if in the, it's smaller than 1 in the multiple choice, then we get it. So we want to know exactly and want to compare how they get their comparison and to see what challenge part for each task. So all this is compared correct. This one is a person who get correct result, and this person is based on the no comparison and get a correct comparison, and this one is get incorrect comparison, incorrect result, but they compare correctly. And we found comparably for question 1, students tended to use a arithmetic way to get the result and to compare it. And for question 4, students kind of don't know what to do. They just pick up an answer. And this is question 2, students tended to get the wrong answer, but they compare correctly. Do you have a question?
Yeah, so just so I'm seeing percentage goes up to 200%. So is that that stack, percentage of who got the first one and the second one, or what does that really represent? Yeah.
So thank you for asking. Sometimes I ignore this part. So this is the CR and the CC. It means the person get correct result at the same time get the correct comparison. So this is for question 1.
Okay. Got it. So for each question, that makes sense.
Yeah.
Okay.
Thank you. Yeah.
So it could actually go up to 400%.
Yeah, if all them together. Yeah. Thank you. Yeah. I then just compare these numbers to see the general pattern. There may be not significant differences. Yeah. So for this one, we can see even though students get a comparison right or even get the final result right, it doesn't mean they get a process right. And for the second, if we see the students who tend not to compare, we found a really huge percentage, like 8% of students for question 1, they get the correct answer. Let's get a 1924, but they tend to not compare. And there's a bunch of them get it correct and compare it wrongly. I think that is really surprised me, and we will talk later about examples. And for this part, it's students tend to give up. More tend to give up because for this question, in fact, we just select one question, but some students just choose several options. So we treat that as you kind of do not know anything about their context. And next one is to see the person who do not compare correctly. So the person for question 3, you can see the students get the correct result and compare incorrectly. Question 3, there's some good examples I will show later. And this one, the students get no responding, but they get incorrect result because I think question 3 and question 4, it's students tend to, if you give them some options, they tend to take risk and check one, right? But here students do not, And this one, and incorrect response and the same pattern of question 3 and question 4, there's some question about if you give the option to them, if you do not ask any work, they may tend just to guess and give some responding. Okay, and this is the distribution of question 1 to question 4 to all the 9 categories and identify which one is outstanding for each category. And I found like, it's very challenging for students do the comparison in question 2 and the question 3 and 4. And it's very challenging for them to do the operation in question 2. And question is also hard for them to do to operation. And let's see the detailed examples. Consider each question. For the question 1, Oh, this is surprised me most because you can see students can follow really great procedure to solve that problem, and which is I think from the literature and from our experience, no students can have really hard time to add two numbers together, with unlike denominator get it correct, and we can see teachers really put efforts to change this situation, right? But at the same time, we think if you arrive this number, you should know it's less than one or bigger than one, because that's the beginning of the concept when we talk about sharing, right? But no, it seems students who are really kind of good students in the classroom do not know really how to compare. They lack that kind of maybe number sense or maybe say estimation strategy. And from the 203 tasks, we find only one student using their estimation strategy correct.
Oh,
Only one.
wow.
I guess I'm not surprised, but
It's
a scary-
sad.
Yeah, it's a scary thought, yeah.
Yeah,
And you said this is out of 10 classrooms, right?
yeah,
So
10
it's not just one.
classrooms. Yeah.
Is it all the same district?
Yes,
No,
right.
they're, we asked P16 to find school contacts
Uh-huh.
that were spread across the state. So there's teachers from Gary and Indianapolis and
These are
around here.
totally
and
different parts of the state.
There's some classrooms that are in the same district, like up to two. But there's probably 8 districts.
This is representative of all of Indiana. Or not-
Represented is
okay,
a strong
yeah.
claim.
It is a smattering
It's
from
diverse.
people that we have
Yeah.
contact with.
Yeah, it's quite diverse.
Yeah, okay.
So is there some literature that talks about, because I see like 19/24, right, is numbers bigger than 10. Let's say if the students were given numbers that's less than 10, let's say 8/10 or 7/10 or 7/8, do you think they might be able to do better comparison?
Yeah,
compared
I think that's a good question, but maybe it's not really. Let me see. Show you one example just now. Here you can see people get 3/11, and they say it's larger than 1. So I mean, if students lack that kind of understanding, it could happen everywhere. But it's 2. It's if the number get larger, it's challenge more than smaller number. But it's an issue, I think. Okay. And there's one student draw a beautiful picture to show the situation, and it say it's larger than 1. You know, you understand? Yeah, it show everything very correct, but we don't understand that one. So I think this is something maybe the teacher really need to think about in their instruction, to talk about how to understand a fraction. And
Can I just double check?
Okay.
So one kid out of all these classrooms did it without actually computing it. I mean, did it how you would hope that they would do it.
Yeah, they said
Estimated.
something like an 1/8 is less than a third.
Third.
So an
Boom.
1/8 plus
Yeah.
2/3 is less than 1.
And
Yeah.
only
Yeah.
one kid.
One
did that.
student.
Okay.
yeah, one kid do that way. Yeah.
Might there be like 20 students who did that in their head and didn't explain, or no?
Yeah, so you might go back, Jinqing, to the slides. I think this was one of the categories where they did no, Jinqing coded as no result, so they didn't do any arithmetic, but they still got the correct comparison.
Okay.
So those, it's not clear, right? There's not evidence that they were
Those
reasoning.
guys, okay.
So this is
So
not some
those
kind of.
students,
So a few more students
yeah.
Might
may have,
Right.
But it's small.
yeah.
But then they need to work on their use pictures, words, or symbols to explain. But yeah. Here, so.
Thanks. Do you have any any knowledge of how many of them actually drew pictures?
Mhm.
Very few.
In 4th grade, it was much higher. In 5th grade, it was quite rare, actually. And I think from our interviews of a number of these teachers, there's an instructional focus to shift away from drawing pictures, which I think is premature in 5th grade.
It's premature in
Yeah.
7th
But
grade.
but I think
Something too immature or.
yeah. So I think the teachers feel like that's useful to introduce things. It's useful to kind of understand what's going on. But as quickly as we can, let's move you over to working with symbols.
Pictures aren't really math.
No,
Yeah.
they're crutch.
And this is, I don't know if you're going to come back to this, but I'll just mention it here since we're discussing it. Estimation, I think only a handful of the 20 teachers we interviewed, 3, I think, recognized this problem as an estimation problem. When they solved it themselves, they all worked out the algorithm before comparing. So they didn't
I was curious
recognize
about
it
that, but that's
as an
probably-
opportunity
Yeah.
for estimation. I think estimation just isn't a major focus in the curriculum.
Yeah, and when I search their estimation in their standard, I did not see clear things anywhere. So I
That's
think
what I was
that's
wondering
also-
if it's, because we would, so I taught 6th grade science, right? So sort of the next year from these kids. And I would try to talk to them really consistently about estimating and getting a ballpark sense of what they think the answer could be before they would calculate it, to give them a sense of sort of whether or not, almost as an internal check of whether or not they were right or wrong.
Yeah.
But I was going to ask you, like, how you guys teach estimation, because it seems like we teach it where it's much more of you calculate the answer. And
Yeah.
estimation is just a thing you develop maybe when you're older or something. I don't
The
know.
5th grade, my daughter's in 5th grade, and so she estimation for like that's one of their standards, but it comes out as rounding. And so they learn procedures for rounding,
Yeah.
and they don't actually apply estimation in other problems. So it's a separate procedure. So I just had to work with her on, why would you ever round to the 10th or to
And why in mathematics would we ever go away from precision? Like,
right, exactly.
It's a non-precise thing. So like,
But it just doesn't cross the boundary
it seems to
into,
go against the.
they would never think about using rounding or in a problem with fractions, because it's something you do with decimals.
I think in my country, my learning experience, even the first class we introduced the fraction, teacher will ask this kind of question. Do you think this one is larger than 1 or smaller than 1? At the beginning, they introduced the concept. Say concept is, if this means it's you have 19 things or 19 words and divided words, and you think about that way. And we work with larger number, even 1900, 1991, and then it's over 1,000 or something. Then you get that sense at the beginning when you introduce the concept, because even if you know the concept, you should infer from that concept the definition. So anyway, and another thing we did not present here, we discussed a lot. There's some pattern with classrooms. So for the students who really do this, it happened I think 2 or 3 is happening in one classroom.
Where they
Yeah,
misidentify it.
so it's really about the teacher maybe did not cover anything about that in that classroom. Okay, the next one, you can see, if you see the example, it's kind of students get a good sense to say it's smaller than 10, no matter what, it's smaller than 10, right? And they try to use their arithmetic operation, and there are so many ways to make them, there's so many ways for them to make mistakes. So I found there's kind of 3 common way. The first one is they just align the points incorrectly. They did not align the decimal point.
And I assume on that, basically they put the 8 under, the 8.9 under, they just shifted everything over and had 4 numbers in each column.
Yeah. And then sometimes they just drop 1 number if they
Oh,
found
okay.
one more.
We don't need that,
Yeah. They drop 1 more. And they have a regrouping thing. So either they're not regrouping or they forget to take 1 out. And even they put 1 there, they forget it. So, and the third one is sometimes they get 16 minus 7, it's 8. Just make that kind of mistake. And some students always get their larger number, subtract their smaller number, always. So no matter where you are. So I will use the larger one to minus the smaller one. The 5 one, it's some students mixed because if you see here, 7,
They multiplied.
yeah, the multiplication, the decimal, so they get it. Because you have 2 and I have 3, though you need to have 5. So that's kind of information. For this question, students tend to, if their difference is a little bit larger, for them it's easier to compare correctly. And they have some sense of the number. If you say, oh, it's 16 minus about 8, it should be smaller than 1. But it's really challenging for them to get the number correctly. And there's some mistake happened there. The question 3, it's very surprised also because they tended to get the correct. You can see the people get reduced here. It's 4 on the 408, and these people even know how to reduce it. And these students have a multiple way to figure out what the number is. It's 4 and remainder 4, and the 4 remainder 4. But when you see what they choose, is surprise, right? So these students think is between 4 and 6, or 6 and 7. And normally they tend to believe that it's 3 to 4. So there's a bunch of students believe, even though they get this correct answer, but they tend to believe that it's 3 and 4. So that is question 3. And then question 4 is very interesting if you can see the context.
Cheers.
Yeah, it's
This is pizza.
they do not say any detailed things. And that's we have a bunch of students do not use any work. We said arithmetic work there. They just draw something there and give you the right answer. So I think that's some implication is students, if you give the context to them, they kind of know what happened there. Kind of know the number should be what. But if you push them to use arithmetic method and push them to use a procedure, it's kind of struggle. It's much more struggle than they figure out in the man. So I think it's something shows some strengths of their understanding of a number. In fact, maybe we just needed them in the wrong way. So, and another thing is when we see, okay, why students cannot use arithmetic way to express their idea. And I think that is also a challenge. It's because they did not combine their understanding of the word with the mathematical language. It's not a very good combination or coordination with those. So it's hard for them to say, oh, should be 8 and over 10 in that way.
Yeah, it certainly seems that the operation in number 4 is much less clear than it is in the other 3 problems.
Yeah.
Do you have a sense that like one of them shaded in looked like one at the top left looks like you shaded in 1 out of 10 pieces?
I don't know.
And so I'm wondering how much, whether they're getting between 0 and 1 because they're breaking one whole pizza into 10 pieces. And so 1 piece is less than 1.
Oh, you mean?
Or
their
whether
reasoning
they're
is
like whether they're ignoring the 8 ounces altogether.
Yeah,
Like are
yeah.
they actually sprinkling cheese?
Yeah.
Or are
That's
they just
possible.
looking at that and going, oh, it's a fraction pie. I know fraction pies, and I know 1
It's
slice
more
is
than
less than
one.
1.
Fractions are always less than 1.
Yeah. That's possible. Yeah, that's possible. Yeah. That's really interesting. And I think it's really possible.
You guys just interview the teachers, right? Not the students.
Hmm?
Did you guys interview the students or just the teachers?
The
Just the
teachers.
teachers.
We did not interview the student. And when the teacher I interviewed, she feel really struggle about this question because she feel like, okay, it's really challenge. So which number divide each number? And he go back and forth several times.
Ooh, so what would happen? Sorry. What would happen in this question if you're, instead of the options of 0 and 1, 1 and 2, 2 and 3,
Yeah.
you did like 0 and 1/10, 1/10 and
Okay.
1/4. Like
Yeah.
if the options were fractions instead of,
Yeah. I feel that's really
it'd
challenging.
be interesting. So, oh yeah. Then they just
Yeah.
be guessing.
Okay.
Some other interesting errors on this though were people that picked 8 and 9 or 9 and 10 because they saw the number.
This one?
So this
Oh,
one.
yeah.
Yeah.
Oh yeah, yeah.
So,
that's
so
right on there.
would this one on this page be a correct calculation but an incorrect comparison?
Yeah.
Is that how you'd code that?
Yeah. And yeah, this one, in fact, I have the same pattern with this one. So some students use 8/10, and then they get a 5/4. So either they get a 5/4, 4/5, or get 9/10, or something else. So they have the same pattern with this because they use 8 divided by 10, or some student makes mistake, it's 10 divided by 8. And then they didn't know what happened here. One student think R1 remainder 2 is equal 1/2, and it's between 1 and 2. So all C numbers there, right? Perfect reasoning, yeah. So it's this ways. And okay, finally, we want to say, if we really looking student work, if one teacher in the classroom just looking the 15 to 25 students work in my classroom, I think they can really find something interesting for their class or reflect their instruction in the classroom. And so from this discussion, we found something interesting is from the test perspective, it's how you design the test. It really matters how students respond to the test. And, people is really smart to make some benefit choice by themselves. So, and generally feel like the student, there's something like if we compare question 1 to question 4, if the content is heavily talked by the teachers, I think students tend to make little risk to choose the answer, to make a judgment. Because I think, okay, there's something I don't know. But if something they feel like, oh, it's really new, they're trying to do new things, no matter what. 2, I think from this, we need the teacher, at least those 10 classes teachers, to really think about a coordinate or fraction decimal with whole numbers, put all the number in the system. It's not very independent. And develop their decimal addition and the subtraction fluency. I think it's not only about they operate correctly, they need to know why we do that way. And stress students' conceptual understanding of fraction, you can see, I think most of this question can go back to what the understanding of fraction, especially when they compare numbers. If they know at least the definition of the fraction, maybe they can make more sense of the number, how large of the number. The third one is something we say, the procedure fluency does not always imply deeper conceptual understanding, and teachers still tend to teach procedurally from their work. We see sometimes we can't really believe if the students can perform very advanced thing. Like if they can add 2 fractions together correctly, seems they're really good about fraction, right? We believe it if we just tested that part, but it's not. Yeah, that's something. Thank you, and especially thank Jackson. Thank you. I worked with him a lot, and he was real nice, gave really good feedback. I worked so long time together. Thank you so much. Yeah, thank you. Okay, do you have any feedbacks?
So we saw, one thing I'll say is, I'll say one thing and ask one thing.
Okay.
With the last point you made, number 3, when we were looking at data visualization, understanding of data visualizations, we see something very similar to this, which is even with college students, when we would say, here's sort of a table of data, how would you visualize these data? they would pick probably the right type of visualization, but if you ask them why they made that choice, they would come up with all sorts of sort of silly responses. One of my favorites being this kid he was definitely not a STEM major, was like, oh, that's my favorite type of graph. It's like, you don't have the right to have a favorite type of graph at this stage.
Could I just say something real quick, building off that from the interviews with teachers, which was when we were talking about the representations they used. I was surprised by how frequently they said things like, I really like number lines, which is why I emphasize them in my classroom.
Right. Do you have them in your house? Like,
Do you have any
So
idea
I
what
think
your
there's
kids
something
interpret
related
from
there
them?
about it's this kind of meta representation, like, anyways.
No, I just,
Yeah.
but I think it always came back to us of like, it becomes, and it's like, it's exactly, I think, the way you've laid it out here, where they might know how to calculate something, they might know how to do something, they might know how to put those numbers into Excel, create a graph, or draw it by hand. But they're not really clear why they're making that choice, or why one thing
Or
might
what
be
it
better.
shows differently than
Yeah.
another representation would show.
Right.
Like, what quantitative relationship are you trying to investigate?
Yeah, and we talk about this in science quite a bit as well, of students can report back to you an answer the way you'd want it, but if you really try to dig into, do they really understand the concepts underneath it, it's probably not there, or in few students. My question was going to be, or is, if you all, as experts in math ed, value estimation, then how would you recommend, say I'm a novice teacher, how would you recommend that I actually teach it to my students? And let's say 5th grade as irrelevant.
Well, Jinxing was saying a little bit about that. You said when you were introduced to fractions,
Yeah.
Right.
they would talk about a fraction first that was maybe more complicated than the ones they'd be expecting you to compute with, like 19 over 24.
Yeah,
Like-
yeah.
Talk about what that means first and have a discussion before you ever compute with it.
So yeah, it's
Do a
at the
whole,
beginning you may introduce students fraction from 1/2, 1/4, 1/3, so simple numbers. After they get that understanding of fraction, then teacher immediately challenges them some strange number. But it's really power the students to say, okay, if I know this concept, I can know all the numbers, not only 1/2, 1/3, but any number happening this way, I understand what the meaning. So I think that's a way to get a little bit of challenge for students. And in fact, students really can understand about that. But I think we tend to not do that way, even for teacher education. So in the summer, I'm working Eric Galinda's project. We asked teacher one question to compare. It's 1099 over 2000. It's smaller or larger than 2000 over 2001. And this question, and they really challenged, but they should know. I mean, the knowledge is able to help them to solve that question, but it's just a surprise. We don't know, it's number too much, and we don't know how to teach, and we don't know how to solve it. But after the discussion and group working, they find out, and they feel happy if they find out that thing. And they say, oh, mathematics, if in fact the concept is really powerful for you to make a decision when you really know that. It's, you just don't know. And I mean, in order to help them, I say, okay, how about 2/3 and 2/3 and a 3/4? No, 2/3 and a 3/4. If you cannot solve that problem, let me solve a smaller one. And they say, oh, of course I know. And how do you know? And they say, okay, because there's one piece missing, and there's one piece missing. And I say, okay, the same situation, right? And they do that way, and they understand, okay, because, and they have come up so many ways to reasoning why it's smaller or bigger. And then I say, okay, is it possible for you to create a question, similar question by yourself, and challenge each other, and make it really scared at the beginning, but you can solve it? So I just think maybe just some experience to say to challenge and get people from the comfortable. Sometimes I think if you put the content in the extreme way, in fact, it's easier to make it more clear. Extreme way, right?
Yeah, as another good way I think to go to the extremes is to ask kids like, what's a number which you know is too high or do you know is too low, right? Like this kind of thinking where you're making sense of the problem. I mean, this is so much about sense making and jumping into algorithmic approach to the problems. Like one which is not about estimation, but I recently saw, you probably all know this, but there was this researcher asking this question, like there are 50 sheep in the herd and 3 dogs, how old is the shepherd? And they asked this to like also 5th graders, for example. Like so many kids, like most of the kids would start scribbling things down and just like combining
3 of the 50.
Yeah, so it's in all these areas, the sense making.
Start with saying, what do you know, instead of what don't you know.
Yeah, or maybe just use the student's mistake example and then say, okay, guys, some students think this is larger than 1. Do you agree with that? And why? And maybe show and think and debate. I think the representation sometimes do not work well. It's students view as procedurally to say, okay, that is always teacher go with that when the teacher talking that, but it's not as a tool for me to convince people. Like, okay, when I show that, I say, oh, let me show you what happened here. And then say, do you think, and I want to use the picture to convince you. It's not because I need to learn that way to present. If I understand, I do not need that. And if I can convince you with verbal, I do not need that tool. If it's really hard to people understand, then I say, okay, let me show you. I think you will believe me. And then they say, oh yeah, cool, it's right. Yeah, I agree with you. So yeah, I think that is also about how representation used in the classroom. And there's another topic, it's, I found with another research, it's, at the beginning, I feel like US textbook, it's really fancy. I love it. It's really
Lots of pictures.
Looks fancy, color,
a lot of strategies.
really
right?
heavy.
Lots of strategies. I love it. I say, oh yeah, it's so smart. And I feel like, but if you go to the real classroom, teacher only pick one. And the easiest one for the teacher. It's not the effective one. It's the easiest one. I just feel like I like this one. And they did not explore other strategy. And then just teach that one. So, and I see there's some mismatching from our expectation and what the real works in the classroom.
Yeah, this last point is not at all surprising if you've read any of the last couple of decades of work in education. But I think what is surprising is this is, 3 to 5 years after the rollout of Common Core and a big push, and we was hoping to move the needle in that a little bit.
Yeah.
And how is it being interpreted? How is Common
Yeah.
Core being interpreted by?
Right. Well, I mean, it's not even Common Core. It's just that standards push around using representations to build conceptual understanding, which is present even in the new Indiana standards, for example.
But if the representations themselves become procedural, like envision my daughter's program, they know one representation for multiplication. They know one representation for addition. They know one.
I mean, is that
procedurally?
not to get too theoretical here, but like, is that just an image issue of mathematics? as a whole of, again, it's a precise thing. So why would we play with estimating or drawing pictures if I know the way to get the right answer and I'm going to just churn through and get the right answer that way?
It's certainly the historical perspective.
Oh,
So it's maybe similar in science to this, nature of scientific inquiry or nature of science question. That whole, it seems like half of science education is PR movement to convince people about like what science actually is. And once you're on board with that vision, everything. And I think there's an analogous thing in math, which again is against kind of long-standing entrenched views of what mathematics is.
I think people
It's a way to get the answer right, quickly.
Yeah, so why would you ever tell me to do something to estimate? That's like
Right.
going in the opposite direction.
And they're willing to estimate. They're just willing to teach kids how to round. And so estimation in fractions just never happens. And,
Well, it's interesting. So
it's divorced from
yeah,
anything that's flexible and real. Yeah.
because now that I think about it, so my daughter is in second grade, and last night was showing me some of her math homework, right? 2 nights of math homework a week, where she had blocks, and it was sets of blocks, and what she's supposed to do is sort of do greater than, less than, or equal to. And so that's when before I asked the question, that I was trying to think like if there's something in that procedure where you could bolster how estimation is done, where they're not supposed to color in the numbers or do whatever, but you're just sort of saying like, almost look quickly at this, like is one greater than the other, or what good estimation strategies would be that you could scaffold sort of along the age. Because part of me wonders, like if you gave this to high school kids, would you be getting only slightly better results?
Well, like you said, fourth graders drew more pictures, right?
Yeah.
You said. So it's almost like they have some skills before they actually start teaching them the procedures. They have some ability to wrestle with it. But
I wonder what they would do if you told them answer without calculating. Like, do you think they would actually come up with good strategies themselves?
Yeah, I think that's a good idea. We do not do that, but I think maybe some different, right? If they ask them.
But the point is you want them to know that they don't need to do that, right?
Yeah.
I mean, I almost feel like that last bullet is really, procedural fluency gets in the way of, conceptual understanding. I feel like, particularly if the fourth graders are being a little more conceptual about it, there's some evidence here for that.
and you can also, I think just having teachers say, draw me a picture, show me, prove to me, this calculation didn't do it.
Yeah.
Explain to me unless you can explain every step of this, which most of them probably can't.
Yeah. And I have a question, like, I think competition and speed in education field seems not something we're talking about. But I think there's some good beneficial about that part. Like, do the problem, like, be honest, when I was a student, I do ABCD, the question, and I get the right answer. I did not go detail because I needed to finish the examination and it's time very, and I needed to figure a way to solve it very correctly and very fast. And in that way, I say, if I look in that question, I say, why I needed to go detail? It's smaller than 10, it's larger than 1 cap, and I did not need to really do the work. And in order to increase my accuracy, then I need to use another method to check if it's correct or not. And then I get multiple strategies because I know if I always check if the same strategy, of course I get the same thing at the last. And I think that strategy is not good for me to check the answer. So next time I always figure out another way to check with my answer. If 2-way check the answer correct, I really know, okay, I will get 98, 99, the score I really know what the score I can get. And their test is, I think in their assessment, say how confident you feel this question is correct. And US is really high without, right? It's really high, even though their answer is wrong. Just confident about the answer. Yeah. And I think that is also funny thing. And no, not funny. It's fun. It's interesting. Yeah.
It's funny too.
Yeah.
These days I learned fun and funny is different. But I know it's
That's
funny.
the prize.
So yeah.
That's true across a lot of areas, though. Like I work a bit in retrieval practice, and one of the things is that so actually just retrieving something without looking it up, like without looking on the other side of the flashcard, for example, is like way more powerful than just restudying.
Yeah.
But people are extremely bad in judging whether they got it right or not.
Yeah.
Especially when it goes beyond just, oh, it's that vocabulary.
So I just finished this book by Mark McDaniel called Make It Stick. And he's a cognitive scientist from Washington University in St. Louis. And they've done work on retrieval practice and stuff. And so this sort of brought up that notion of one of the things they talk about is when students, like especially college students, right? You ask them how they study and they say, I reread. And they've shown now in a number of studies that's actually probably the worst possible study approach. But what they talk about is that you fool yourself because you're becoming more fluent with the text.
Yeah.
So you think you understand the underlying concepts, but you actually just know the text better.
Yeah.
And so you trick yourself into thinking that you know it. And then when it, if you get a teacher like you guys and you get a question like this, it sort of throws you because you don't actually understand what it is.
Yeah.
And so I wonder if that's part of what's done here too, if that's sort of reinforced, and then you get a standardized test question that does this, or you're given a problem at home, like a real life problem. You can't really figure it out because you don't actually know what to do in that situation other than to just plug things into.
Yeah, so it's really Needham do not have any flexibility to solve different problems. So even you change one number, they get it wrong.
Yeah.
So that's its issue. And I relate that in the summer I teach some high school students. There's a girl really good at mathematics, so very correctly. And one day I introduced them with famous method, which you need to explain every concept. And she volunteered to go there. And I said, okay, just do me a fraction addition, like 2/3 plus 3/4, something like that. And then she solved it correctly. And I said, explain to me why you do that. And they say, oh, you need to find the common denominator, so the procedure. And then at last, she accepts a lot of challenge, but the one challenge she cannot solve it. I say, why you want to find a common denominator? They say, because they're different unit. I say, why it's different fraction unit, then you cannot add it together? And she say, cannot. It's that kind of feeling stuck there. And then it's push her so much about why you can add a 1 and 1, get a 2. And it's something they say, oh, they find the unit and then show the picture. If you get a 1/3 and a 1/4, you put together whatever happened. And I think from the whole summer section, that's the most thing she learned from her feedback. She mentioned that it's really good to ask. I think her comments is say, it's really important to know if you make any decision in mathematics, you know why. Make any step of mathematical decision, you should know why. I think because, and I asked them, do you have any good math teacher? All the groups, they say, cannot remember any good math teacher. And I say, oh, you guys, mathematics is good, seems good. And they say, yeah, 21st century, there's a lot of videos. If you want to learn, you can always find something from the internet.
I had a teaching.
So they do that way. Yeah.
Can I ask one final question of the group? If you were to guess I won't say estimate, where you'd find more pockets of good estimators. Would they be at the upper end of the distribution of sort of mathematical skill, or would they be in the middle, or would they be at the bottom?
As testing or
Yeah, like if they,
grades
on
or how
a
you
typical math standardized test,
Okay.
if we sort of put them across the spectrum of, whatever performance on that, do you think it's the best students that are where you're going to find more good estimators? The middle, the bottom, or sort of spread?
probably not in the middle.
Yeah. I'm just because part of me is wondering, like, is it the kids that really get it that then use this for speed, or is it the kids who struggle and they find this as an alternate approach that sort of gets them through? Or
Performing arts high school.
Yeah. Nobody's very good at estimating.
right. Well, that's I was gonna.
In the low end, the ethos is we just got to teach them the basics, teach them the skills, and we don't really spend much time getting them to think about what they're doing. We spend most of our time getting them to remember the procedures they need to know for the test. And so I'm suspecting that's not helping at all in terms of estimating.
I think you'll see it at the upper end, especially among boys, less among girls who are good girls and follow the directions.
Yeah.
So do you
And
have
I would
any
guess
other
maybe,
kids?
similarly to that the very high end of the distribution, especially if you're looking at kind of a high school level, I think in college you probably get a little more separation. But your very best students coming out of high school, the system rewards people that can memorize and execute procedures really quickly, much more than it rewards people who can estimate. So, high school students who are doing well in Math Olympiad because they're kind of creative mathematical thinkers are not necessarily going to be the kids who are getting 5s on all their AP. And there might be some overlap, but
The Math Olympian kids would do
would
this
estimate.
efficiently.
Right. Yeah.
Yeah.
But they may. You got to, because that's what happens in college calculus and linear algebra classes. You get everyone coming in who's really good at math in high school, and then all the kids who just memorized, don't move on.
And of course, on the state tests, if there's not a correlation between how well you do on the computation and how well you do on the estimation, they're going to throw out the estimation item anyway.
That's right. This estimation question is really not tracking what you care about.
But part of it goes back to me of thinking of like in my daily life, and I've always wanted to do this in science, but 95% of it, 99% of it is estimation. And very rarely do I actually pull out, the calculator because I need to be more precise in what I'm doing. And I'm thinking of sitting in group meetings with scientists and engineers, and they know that they can calculate the right answer, but as you talk, it's all estimation.
Yeah.
And so just sort of thinking of like that, when we talk about real life math or whatever we're talking about, that it does really seem to be a thing that's important to try to engender in people.
I would guess it's the people that use it out in the world on a regular basis.
Who would
But I
be the
don't know
best
who they-
estimators.
Yeah, I mean, people who are forced to, but that I would put those in a particular, there might be a pocket of shopkeepers and a pocket of engineers, and they would be.
Yeah, whatever, if there's a context where you're using estimation all the time,
Yeah.
those people are going to be good.
Yeah,
But it's
but not because of
not
not
because
with
of any instruction.
any correlation with
Mm.
standardized test scores.
Yeah. Yeah, that's sort of my experience. It's like if they are asked to estimate for various things that they do, like they do a lot of cooking or they build with their mom or dad or whatever, then might be more comfortable playing with this because of dimensions of wood or cups or whatever, but that there's not necessarily like the strongest math kids are the ones who are now estimating and everyone else can't do it.
It would also be interesting, like Jinjing was talking about the fourth graders versus fifth graders. Like if you throw something at them that they're supposed to be estimating before they've learned a procedure to handle it, I wonder if they'd be better than the kids who have already been trained at something.
Yes,
Yeah,
I think there's quite a bit of it, yeah.
there's evidence.
I
to
think,
show
yeah.
that.
I mean,
Yeah, that training's really got
Which is sad.
two sides to it.
Really sad. But it does show that you know, to the extent that we can make that case to teachers, it's like use that, like coming in, use that,
That's.
nurture that instead of, and don't. But I think we also push them to feel like their kids have to leave their classroom in lockstep. Like, and that's where I feel like it's different than science. Like I've been in elementary, I helped out at my daughter's school when they were doing science lessons. And they don't have this feeling in a science lesson like they have to have everything perfect at the end. Like they're tackling ideas and they're discussing ideas, but they don't all have to leave with exactly the same computations and the same definition of something.
That's somewhat of a rarity.
Is it? Okay.
Yeah, I mean, we still fight the battle, and Valerie fights it more than any of the rest of us, of there's not like one method, one procedure in, you know, this nature of science, the way science is done. And so many teachers still teach it as like, nope, we do this first, then we do that. And actually, this is why the estimation question is of interest to me is, you know, students would say like, I've got my answer out to, you know, literally 57th, you know, decimal point here, because that's what Excel told me the answer is. And you'd say, well, okay, compare or just ballpark. Do you think that that should be right? And they think that it has to be this, you know, exact thing, and everyone has to be exactly right. And so we'll try more and more to talk about sort of natural variation and just, it's okay. And this is one reason why we use statistics to like group all of our data together, and there's more power there, you know. So yeah, so if you had that teacher, then you probably lucked out to some degree. So that's good.
And I think the society also influence, because US is really standardized about everything, and that's a powerful part for me. Like I live in US, I feel like no matter where I'm from, I can live here easily because everything is standardized. And
Really?
I mean, if I cook bake anything, right? You just go there with the recipe and put everything, and you get the same at last. And I think that is not happening in the developing countries. Like in China, you really have to estimate a lot of things. You can say, oh, you get this bag of salt, or, you know, you have that kind of feelings. Yeah, you have to.
Here.
And there's not so many instruments help you to
We have our procedures and our instruments, and we use them
Yeah.
from everything from baking a cake to you
Yeah.
name it. Yeah.
Yeah. That's I think is also one factor for that, because that's how the life construct. Like my family do business, they will not count all their bags. They say, oh, this is about how much, how many. And if you do not do the estimation very well, then you will, fail your business. And like people who sell pork in China, I know you are going to visit China, you will see. I say, I want you 1 kilogram of pork. And the people, 1 kilogram. It's almost that. Because if you make a mistake about that, then you will get so many small pieces of pork. And people do not want to buy small pieces, right? It's for real, I don't know. So you need to get a very estimation very well. And when I was a child, I even sell something to other people. And I also have a good sense of estimation, like how much money I will make this time, you know, and how long time you spend. So I think that's is also another perspective, how you living a life without really accurate measurement. Yeah, that's it. One.
Thank you.
Thank you.
Thank you.
So,
Good
to see you, yeah.
Picture out of my, okay.
So is this one is over and you're on
Oh.
something else, or is this?
Oh.
And
So
this
I'm
is
gonna meet with
like
Sarah for a little bit.